Welcome to this tutorial. I'm solving question number 7 of paper 2 to May-June exam series of 2020, and the topic of this question is isotopes and decay equations. The question says radon 222 is an isotope of radon which undergoes a series of radioactive decays. Figure 7.1 is a diagram showing the proton number, atomic number, and the nucleon number, mass number of nuclei involved in the series of decays. The point P represents a nucleus of radon 222. So it starts here and then it goes like this. Then we have this sequence of radioactive decay. Starting at point P, a nucleus of radon 222 decays to Q, then from Q to R, then from R to S, and then from S to T, and finally from T to U. So it ends here. Part A1, state 2 points on figure 7.1 which represent isotopes of the same element. So in this grid, proton numbers are being represented on the vertical axis and nucleon number are being represented on this horizontal axis. So we have to find the points which represent isotopes of the same element. So the points which have the same proton number but different nucleon number, they would be the isotopes of the same element. So for T, the proton number is 84. For Q, the proton number is again 84. T has a nucleon number of 214 and Q has a nucleon number of 218. These two particles have same proton number but different nucleon number. So we could say that T and Q are the points which are representing the isotopes. Similarly, there is another pair. U has a proton number of 82 and R also has a proton number of 82. The nucleon number of U is 210, but for R it is 214. So again we have same number of protons but different nucleon numbers. So another answer could be U and R. The next part says different isotopes of the same element have different atomic compositions. State how the composition of their atoms is different. So the difference is they have different number of neutrons in the nucleus. So this is the difference which is found in the isotopes. A nucleus of radon 222 emits an alpha particle as it decays. The radioactive decay of a single nucleus is random. Explain what is meant by random radioactive decay of a nucleus. So randomness could be described as the time when decay occurs is not constant. So it can occur anytime without any pattern. That is why the radioactive decay is random. The next part says in nuclide notation radon 222 is written as radon Rn 22286. When a nucleus of radon 222 emits an alpha particle, it decays to an isotope of polonium. Complete the decay equation for this decay. So we would start with the details of alpha particles. The proton number of alpha particle is 2 and the mass number is 4. The polonium's proton number could be found by subtracting 2 from 86. So it would be 84 here, and 4 would be subtracted from 222. So the mass number for polonium would be 218. State the number of particles emitted as a nucleus of R decays to a nucleus of S. So R and S. R has a proton number of 82 S has a proton number of 83 over here. And secondly, both have the same nucleon number. So this happens when a beta particle is emitted. In a beta radiation, a neutron converts itself into a proton and an electron or a beta particle. So the proton number increases by 1, the neutron decreases by 1, which means nucleon number would remain the same, but specifically the proton number increases by 1. So the answer for this part would be, state the name of the particle. So we would be writing beta particle. Describe the change in the composition of a nucleus of R as it decays to a nucleus of S. So S has one more proton as compared to R, and secondly, S has one less neutron as compared to R. So this is the difference which is there between the nuclei of S and R. The question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you liked the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.